Today we want to talk about a topic in mathematics, call it surd. It's a topic under mathematics by syllabus. Now what we are saying surd. A surd is an irrational root of a positive real numbers that cannot be expressed as a simple fraction. And surd are typically left in their root form because their exact values are non-terminating and non-repeating decimal. That's one of the definition of irrational roots. When I say irrational number, when you have irrational number are numbers that are non-terminating and non-repeating decimal. That's why most irrational numbers are square root of the numbers or cube root. But surd here is an irrational root of a positive real number. For example, now, if I say root 2, if I say root 3, these are surd, root 5. If you say root 4, you know root 4 is 2. So that's not a surd because the final answer we get there is still 2. So that's what we mean by surd. Now, when we are talking about properties of surd now, properties of surd, one, we have what we call a multiplication property. What do I mean? If I say root A multiplied by root B, that means I'm saying the answer is root means AB. And if I have root A multiplying root B, the property of surd is just I will just multiply what is inside of surd, inside that root. That's A multiplied by B. That means I have root AB. Now, you need to know that for doing this, we are saying for A comma B greater than or equals to 0. A comma B greater than or equals to 0. So when you see surd multiplying a surd, root A multiplying root B, the resulting this thing is root A B. And the second one there is, I can call it a divisional property. If I have root A divided by root B, I can rewrite it as combining it in the single root and saying A over B. So if you have root A divided by root B, you can have it as a single root of having A over B. Now the third one I want us to see here, just a way to dance around. So if you have square root of A or square, don't forget when we have a square root and we have a square and a square root we cancel. So that means we have what we call a square root of A or square is the meaning of A. Or we can say what it means is you say root A times root A. And this is root A square. And this square and square root we cancel and we still have our A. We still have our A. Now another property I would like us to see is when we have something as the fourth one, when we have something as B root A. In what other way can we simplify this? Don't forget that for this B to be outside this square root, that means something will have happened inside the square root for us to be able to factor it out like this. And what we are trying to say is I want to create a root for B. So another way to write B, I can say it is root B square. Because I know root B square will still give me B multiplied by root A. So I can rewrite this as root B square multiplied by A. And by so doing, I can combine these two saying into a single root of B square A. Of B square A. So if you have something like this, I can write it in this form. Because if I simplify this further, I will come back to this. If I simplify it further. So let's do some simplification of surd. Now, the simplification of surd is, for example, when we have a bigger number inside our square root, can't just leave it like that. That means we need to simplify it to make it maybe a smaller thing that we can deal with. So when we have a surd with bigger numbers can be simplified by extracting out a perfect square. Surd with bigger numbers can be simplified by extracting out a perfect square. So what I'm saying, for example, now we have something like root 147. So in order to simplify this, I'm looking for how do I extract a perfect square out of this in such that when I find the square root of that perfect square, it will give me a whole number. So that means I will have to look for a factors that give me 149. And out of the factors that give me 147, I'm looking for the one that will have a perfect square there. So if you look at it, if you press our calculator, you see 147 is 49 times 3. It's 49 times, and that 149 here is a perfect square. 49 here is a perfect square. If we apply our multiplication law, it's written as root 49 times root 3. And root 49 is 7. Multiplied by root 3 will give us 7 root 3. So this is a simplification of surd. That means root 147 is the same thing as 7 root 3. We have simplified it. Let's say for another example, we have root 32. Now, if you look at the factors of 32, you can say it is 8 times 4. Some can say it is 2 times 16. But the best one to pick here is 2 times 16, because 16 is a perfect square. So we say it's root 16 times root 2. And root 16 is 4. That means we have 4 root 2. Now, for somebody that wants to solve root 32 and he or she picks 8 times 4, that's a long process, because we can still break 8 down, and I can still break, that means I'm saying root 8 times root 4. So this one can still be break down to root 4 times 2. And don't forget, root 4 is 2. So this also can still be break down as root 4 times root 2 times 2. So root 4 is 2 times 2, 4. We still come back to root 2, 4 root 2, but the process is done, because not only 4 here, 4 here is also a perfect square, but it's not the highest perfect square you can get from 32. It's not the highest perfect square you can get from 32. So when you are looking for a factor, just check the highest perfect square you can get from that number, and that will make it easier to simplify. It will make it easier to simplify. Now, the next one I would like us to do is what we call a rationalization of surd. Sometimes we call this rationalization of denominators. Now, what do you mean by rationalization of surd, or we say denominator? That means what we are trying to say, we have a surd in the form of a fraction. That means the denominator is a surd. If our denominator is a surd, how do we simplify it or express it? Now, it is in two cases. Now, if the denominator is just a single surd, it's just a single surd. If the denominator is a single surd, what am I saying? That means if you have something like this, let me say 1 minus root 3 over root 2. You see, this is just a single surd at the denominator. So what do we do to simplify it? That means we get rid of this single surd by multiplying it with this surd as a fraction, writing it in the form of root 2 over root 2. And don't forget, root 2 over root 2 is 1. Yes, I'm multiplying this with 1. But that one, I'm having it in the form of this denominator. That's root 2 over root 2. Because if root 2 multiply root 2 here, it becomes a whole number. That's 2. That is what we want to achieve. We don't want a surd, to be the denominator. So if you have a single root, this is the way to go about it. You just multiply that denominator in this form. So when we multiply this now, what do we have? That means we are saying root 2 into bracket 1 minus root 3 divided by root 2 times root 2. So in simplifying this further, it's just saying root 2 times 1, that's root 2 minus. Now root 2 times root 3, that's our multiplication of surd. That means we have root 6 divided by root 2 times root 2, that will give us root 4, and root 4 is 2. Root 4 is 2. So this is the way to simplify this one. You see that the denominator now has turned from being a surd to a whole number. So that's how we do when we have a denominator as a single surd. But the second part of this is when we have a denominator as not a single surd. That means we have it in this form. We have it in this form. That means 2 plus root 3 divided by 2 root 3 minus 3 root 2. Now you see that this denominator is not a single surd. It's not a single. So we have 2 root 3 minus 3 root 2. So how do we get this one solved? It's different from the one when we have a single solve. So that means to get this one solved, we need to find what there is something in solve. We call it conjugate. We call it conjugate. Sorry, conjugate. What do you mean by conjugate of it? So you have root 5 minus root 3. The conjugate of root 5 minus root 3 is root 5 plus root 3. That's the conjugate. Just like this addition, this subtraction turns to addition. And if it is addition before, it turns to subtraction. Now we have 1 minus root 3. This one turns to 1 plus root 3. This is the conjugate. They are conjugates. When you multiply a surd and its conjugate, it will always give you 1. So if you want to confirm if truly these are conjugates of each other, that means multiply these all together. That means we are saying 5 root 5 minus root 3 multiplied by root 5 plus root 3. You see, at the end of the day, we have a unit there. So look at this too. If you have 2 root 5 plus 3 root 3, the conjugate here is 2 root 5 minus 3 root 3. That's the conjugate. That is the conjugate. So what I'm saying, when you multiply a surd and its conjugate, just get a number. Now look at this. Just pick one and confirm. If I say root 5 minus root 3, I multiply it by its conjugate. Root 5 plus root 3. You see what we have here is just like a difference of 2 squared. When you have a squared minus b squared, what do? We say a plus b, a minus b. Look at this. It's just root 5 plus root 3 and root 5. So what we are saying is just saying root 5 all squared minus root 3 all squared. That's just it. Root 5 all squared. Don't forget the square. We cancel the square root. That will be 5 minus root 3 all squared. So you cancel the square and that will be 3. So 5 minus 3, you see, just have a number. That's how to confirm if it's a conjugate. But if you multiply something and you still have a surd inside it, that means it is not a conjugate. So the first thing we do here is to find the conjugate of this. And the conjugate of 2 root 3 minus 3 root 2 is, say, 2 root 3 plus 3 root 2. That's a conjugate. So once you're able to get the conjugate, you now multiply it with this surd in the form of this. We say 2 plus root 3 over 2 root 3 minus 3 root 2 multiplied by this conjugate in form of fraction. That means 2 root 3 plus 3 root 2 divided by 2 root 3 plus 3 root 2. So by this now you can now multiply it and have this something like this. 2 plus root 3, bracket is like that. 2 root 3 plus 3 root 2. Everything divided by 2 root 3 minus 3 root 2 into bracket 2 root 3 plus 3 root 2. And this now leads to expansion. This leads to expansion. And now expand and get our answers. How do we expand this now? How do we expand this? Now, if we are expanding this, look at the way we expand it, just to make it simpler. How to make it simpler? Now, once we expand this, now, so I will say 2 into brackets 2 root 3 plus 3 root 2. Are we following? Plus root 3 into brackets. It's just the normal expansion we do in algebra. The same thing, 2 root 3 plus 3 root 2 divided by, if you look at our this now, the denominator is in form of this difference of 2 squared. You have minus and you have plus here. So it's just saying that, just say 2 root 3 all squared minus 3 root 2 all squared. That's the fastest way to get it. That means you say 2 root 3 all squared because it's like different of 2 squared. So that will becomes, you say 2 root 3 everything squared minus 3 root 2 all squared. Now don't make the mistake of writing 3 root 2 first, because in this conjugate, what we first have here is 2 root 3 before minus 3 root 2. Even here, 2 root 3 before plus 3 root 2. We don't go and say, now here, now you now have 3 root 2 minus, no. You have to first write what we have, 2 root 3 minus 3 root 2. Now let's simplify this further. 2 multiplied by 2 root 3. 2 here is just a whole number. So it will multiply the whole number that is attached to this square root. That's 2 times 2. That will be 4 root 3. Plus the same thing here, it's multiply the whole number. Yeah, that's 2 times 3. That will be 6 root 2 plus root 3 now is a surd. And the whole number outside here, we can see it is 1. So if we say 1 times 2, we will still have 2. Now root 3 times root 3, that's root 9. Root 3 times root 3, that's root 9. And root 9 is 3. So we are saying 2 times 3 here. Plus root 3 times 2, 3 root 2. Now look at this. Don't forget I say the whole number outside this root 3 can be say is 1. So 1 times 3 will still be 3. So root 3 times root 3, that will be root 6. All divided by. Now, the first thing you are going to do here, 2 root 3 all square. Everything inside this bracket will own this square. So 2 square, that will be 4. Multiply by root 3 square. The square root and the square will cancel. And that will be have 3. Minus the same thing here, 3 square, that's 9. Times root 2 all square, that will give us 2. We check. Now let's collect the like times in that. 4 roots, we have 4 root 3 plus 6 root 2 plus 6 plus 3 root 6. Everything divided by this is 12 minus 18. That's 12 minus 18. So what we have here is 4 root 3 plus 6 root 2 plus 3 root 6 plus 6. Everything divided by minus 6. So that will be our final answer.